Here we go. So what we're doing today is we're going to be graphing sine and cosine functions. Okay, so the calculator we're not going to rely on for this. We're going to rely on your brains.
My brain's a little bubble. Why is it so low?
All right, we're first going to look at the sine of x curve. Y equals the sine of x. Get out your unit circles, please. So, no. All right, so 0 radians. What's the sine of 0 radians? 0. Then we're going to look at pi over 4 radians. What's the sine of pi over 4 radians? Square root of 2 over 2. What about pi over 2 radians? 1. What about 3 pi over 4 radians? Square root of 2 over 2. You're right. What about pi radians? 0. What about 5 pi over 4 radians? There we go. 5 pi over 4 radians is negative square root of 2 over 2. We'll see in a second. Just indulge me. What about 3 pi over 2 radians? Negative 1. And 7 pi over 4 radians. Negative square root of 2 over 2. And finally, 2 pi radians. Don't have to. It's at 0 radians. 2 pi and 0 because it's one time around. Okay, so we just made one loop all the way around the unit circle. Now, what is square root of 2 over 2 on your calculator? Approximately 0.7 what? 0.7071 maybe?
Does that one after his pi say
705 over 4?
That's 5. Yeah, it's just a bad 5. But we already had a 3 up above. There. Now you're unconfused.
I'm just trying to write things.
So we are going to graph these. So you said, well, why'd you go so long to the right? Well, I will show you why we went so long to the right. All right. So let's say that every 2 squares is like pi over 4. So I have 1 pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, 2 pi, 1, 2, 3, 4, 5, 6, 7, 8. There.
Is it beneficial for us to write this out?
You can just look. That's fine.
But is it?
I can't keep up. I can't even see it.
Yeah, you wrote it first.
I wrote down the chart and I'm calling it good from there.
I'll watch.
All right. So at 0, at an x value of 0, we have a y value of 0. Yes, I'm recording this. And next value of pi over 4, I'm at 0.7071, so right about there. At pi over 2, I'm at 1 point, because if I go 2 spaces to get to 1, this is 0.5, so 0.7 is a little above there. Okay. All right. 3 pi over 4 is again 0.7071. Pi is where? 0. And 5 pi over 4 is negative square root 2 over 2, which is negative about right there. 3 pi over 2 is negative 1. 7 pi over 4 is negative 7.7071, and 2 pi is 0. So if we connect the dots, we have what is called a sinusoidal curve. A yeah, I can spell that. Sinusoidal curve. I don't know, but it's a sinusoidal curve. Okay, so let's think about coterminal angles now. Oh. All right. What is 9 pi over 4 the same as? 1 pi over 4, because they're 2 pi apart. 9 pi over 4 is the same as 1 pi over 4, because they're 8 pi over 4 apart. Okay. So 9 pi over 4 would be right there. 10, 11. So 10 pi over 4 would be like right there. 11. Oops. So this would keep going like this in this direction because, and you can keep going around the circle forever. It would never end. So then this way, we would go by here, and you would keep going back this way forever. Okay? Now, from here to here, we say we went 1 period of the function. 1 period. A period was when you start and end at the same place, and then you'd start back again over the exact same place where you ended. So here we started, we went all the way through to here, and then we'd go another one, and then another one, and another one, forever. Okay? So that's 1 period. The amplitude is the difference between the highest point and lowest point divided by 2. Okay? The difference between the highest point and lowest point divided by 2. Okay? So, that's what the sine curve looks like. Are we good with that? Now we're going to look at the cosine curve. At 0, what's cosine of 0? 1. Pi over 4, what's cosine of pi over 4? Square root 2 over 2. How about pi over 2, what's cosine? 3 pi over 4. Yep.
Negative square root of 2 over 2.
Negative square root 2 over 2. Pi. Negative 1. 5 pi over 4. 3 pi over 2. 7 pi over 4. Square root of 2 over 2. And 2 pi. 1. All right, so then we're going to graph this. Instead of starting at 0, 0, we start at 0, 1. Pi over 4, 2 pi over 2. Pi over 2, 0. 3 pi over 4, negative square root of 2 over 2. Pi, negative 1. 5 pi over 4, negative square root of 2 over 2. 3 pi over 2, 0. 7 pi over 4, square root of 2 over 2. 2 pi, 1. So if we would continue on, it would look the same as a sine curve, just shifted over a little bit. Okay? Because it, again, keeps going up and down, just like the sine curve does. Okay? So it is also a sinusoidal curve. Okay? The period goes from there to there, because it goes from there to there and it starts repeating again. So that's 1 period long. Okay? So what we're going to do with these graphs is we're going to make some shifts in them. We're going to shift them to the left, right, up, down, all kinds of things. Okay? So what we're going to work on right now is adding and subtracting to shift them around. So if we have the point like pi over 4, 2. And I want to shift that point. And I want to shift that point pi over 2 to the right. Where will that point end up? So if we're talking about right and left, it affects the x value. If we're talking about up or down, we're going to affect the y value. So what is pi over 4 plus pi over 2? 3 pi over 4. Easy peasy lemon squeezy. What if we have pi over 3, negative 1? We're going to shift pi over 2 right and up 2. All right. Pi over 3 plus pi over 2, we need to get a common denominator. So pi over 3 is 2 pi over 6. pi over 2 is 3 pi over 6. So what do I end up with? 5 pi over 6. And then negative 1 plus 2 is? Negative 1 plus 2? 1. Ta-da. So can you make ordered pairs by shifting things around? That's pretty easy, right? Let's do one more. Let's say we're at negative pi over 4. Negative 1. And we're going to shift pi over 3 to the left and 1 down. Well, if we're at negative pi over 4 and we're going to the left pi over 3, then what would I do? Add or subtract? Subtract pi over 3. So I need a common denominator. What's the common denominator between 4 and 3? 12. So it's 3 pi over 12 negative minus 4 pi over 12. And I get negative 3 minus 4 is negative 7 pi over 12. And then negative 1 minus 1 is negative 2. Okay? All right. I want to find a point halfway in between those 2 points. To find a point halfway in between pi over 2 and 3 pi over 4, we add them up and divide by 2 because it's the average. Halfway in between is the average. So you take pi over 2 plus 3 pi over 4 divided by 2. And then 6 plus 6 divided by 2. Well, pi over 2 is what over 4? 2 pi over 4, right? So 2 pi over 4 plus 3 pi over 4 is 5 pi over 4 over 2. Well, this is 2 over 1 in the denominator, right? So when we have a complex fraction, multiply by the numerator times the reciprocal of the denominator. And we get 5 pi over 8. And then the y value, 6 plus 6 is 12 divided by 2 is back to 6 again. Halfway in between. Just add them up and divide by 2. Do that one more time. Let's say we're at negative pi over 3, negative 1, and pi negative 1. What's halfway in between those two? Well, we have to take negative pi over 3 plus pi, which is 3 pi over 3, right? Divided by 2. So negative 1 pi over 3 plus 3 pi over 3 is 2 pi over 3 divided by 2. So when we divide by 2, it's the same as multiplying by 1/2. The 2's cancel. So it's pi over 3. So the point halfway in between is pi over 3, negative 1. We good? We done? Good. So your first assignment won't be any graphing. You won't have to graph. You're just working with ordered pairs. And it is 9 through 47. What? 9 through 47? That's like a lot of questions. 9 through 47. Just a second. It should be 9 through 49. Excuse me.
What? Even better.
every other odd. So it's 9, 13, 17, yada, yada, yada on page 116.
116. That's so complicated. I'm gonna just circle them and call it a day.